Today we start a unit on solids. By solids, we're talking about three-dimensional figures. So here are some examples of some three-dimensional figures. Here we have what we call a prism. Here's a cylinder, a pyramid, a cone, and a sphere. Now when we talk about solids, there are a number of terms that we need to understand. First term is a face. When we talk about the faces of a solid, we're talking about the flat surfaces that make up that three-dimensional shape. The edges of a solid are the lines where the faces meet. And then the vertices of a solid are the points where three or more faces meet. Now let's talk about different types of faces and surfaces. So the first kind that you'll see is a base. This can be the bottom and or the top of a solid. So for example, prisms and cylinders have two congruent parallel bases. So here's an example that you can see visually. There is a surface that's up at the top and one on the bottom. The base is usually a little easier to understand because that's where the three-dimensional object is making contact with a table, for example. And if there is a surface on that object that is parallel to it at the top, we also call that a base. Now for cones and pyramids, they have one base that is opposite the vertex or the tip. So you can see here, in these two examples, there's no surface up at the top that's parallel to the base at the bottom, in which case we would say that these only have one base. The other type of face is a lateral face or a lateral surface, and these are the rest of the faces, so all faces or surfaces that are not bases. Now for a prism, lateral faces are congruent parallelograms. So you can see here a prism. Now the bases you can see are hexagons, but the faces, the lateral faces, are all congruent parallelograms. For a cylinder, the lateral surface area is actually a rectangle. So here's a cylinder, and you can see the base at the top is a circle, the base on the bottom is a circle, and then the blue part here, that's the lateral surface. So if you try to imagine a can, and you were to take the label off of that can, that can be thought of as the lateral surface. Now if you take that label off the can, it's actually a rectangle, right? So if you were to take that apart, you'd see that the lateral surface is just a rectangle. All right, and then a pyramid has lateral faces that are congruent triangles. So here is a pyramid, for example, and you can see here that on the bottom you have the base, but the other faces are all triangles. And the last one is a cone. Now for a cone, the lateral surface is actually just part of a circle. So here's the cone. You can see the base, the circular base on the bottom. And if you were, this is kind of thinking about this like a party hat, and you were to kind of cut a slit down from the tip to the bottom there, and you were to unwrap it, this is what it would end up looking like. And so you can see here that this is just part of a circle, it's not a full circle. Now for the solids that we're going to be working with what we call right solids. What this means is that they quote-unquote stand up straight and their base or bases are perpendicular to their heights. So here, for example, you can see on the left we have an example of a right solid because the base and the height are perpendicular to one another. But on the right, we have an example where clearly the base and the height are not perpendicular. So the case on the right, we are not going to be working with those examples in this class. Now in prisms and cylinders, the height is the perpendicular distance between the bases. So you can see here that between the top and the bottom bases, the height is perpendicular to both of those bases. So that is the distance between the bases. Same with the example on the right. Now in cones and pyramids, the height is the perpendicular distance from the base to the vertex. The height is inside of the solid. So if you see in these pictures here, if you were to draw a line along the side, it would no longer be perpendicular to the base. So the height, when it comes to cones and pyramids, which we have here, the height is inside of the solid and it's still perpendicular to the base. Now pyramids and cones have a slant height, which is denoted by L, which is the distance from the vertex to the edge of the base. And we call this the height of the lateral surface. So you can see here a cone and a pyramid. That slanted measurement is called the slant height. So it's the measure from the vertex at the top to the edge of the base on the bottom. Now, when we talk about three-dimensional solids, we want to talk specifically about what we call polyhedron. So polyhedron is a solid that is made up of all polygons. Now, we need to be able to differentiate between these. So prisms and pyramids, those are examples of polyhedron. You can see that the prism, all the surfaces are made of rectangles here. For the pyramid, all the surfaces are either triangles or squares. Now on the other side, we have a cylinder, a cone, and a sphere. These are not polyhedron because they do have surfaces that are in the shape of a circle, for example, for the cylinder. So although the lateral surfaces of a cylinder is a rectangle, the bases are circles, and we know that circles are not polygons. Same thing with the cone and the sphere. So of the solids that we've learned today, prisms and pyramids are the only ones that are polyhedron. Now, when we're naming polyhedron, we typically name them by the shape of the base. So in this first example, we see the shape of the base is a pentagon. And because it has a base on the top and on the bottom, we would say this is a pentagonal prism. Now for the second one here, we have a base that is a triangle, and we don't have two bases, we just have one. Instead, we have a vertex up at the top, so we would call this a triangular pyramid. Okay, take a look at these examples. Tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Let's look at the first one. This solid is formed by polygons. It's all rectangles, it looks like. So we would say it is a polyhedron. Now we see that the two bases are congruent rectangles, so we can call it a rectangular prism. Now in terms of the number of faces, vertices, and edges, faces, think of this as the surfaces. So it looks like we have the one on top and on the bottom, the one in the front and the back, and the left and the right. So it looks like there are 6 faces here. Vertices, those would be the corners. It looks like we have 4 on top and 4 on the bottom, so we have 8 vertices. And in terms of the edges, it looks like we have 4 in front, 4 in back, and 4 on the side, so that would be 12 edges. Let's look at the next one. This solid, it looks like it is completely made up of triangles and a hexagon. So we would say this is a polyhedron. Now, how would we name this polyhedron? Well, since the base is a hexagon and it only has one base, we would call it a hexagonal pyramid. Now, how many faces does this have? It has the one on the bottom, and it has 6 going around, so that would be 7 faces altogether. And then the number of vertices, that would be the number of points. So it looks like we have the 6 at the bottom and the 1 up at the top, so 7 vertices. And then the number of edges, we have 6 along the bottom and then 6 along the triangles. So that would be 12 edges altogether. Okay, the last one, since this has a curved surface, due to the fact that it has a circular face, this is not going to be a polyhedron. Alright, last we're going to talk about cross-sections. So for cross-sections, imagine that a plane slices through a solid. A cross-section is the intersection of the plane and that solid. So here is a visual for you. You can see a pyramid that's being sliced through by this plane. And the intersection of those two, that cross-section you can see there, is a triangle. So let's look at some more examples and see if we can describe the cross-sections here. So in the first one, the cross-section here looks like it's going to be a square. Now in the second one, this cross-section is not going to be a square, although it looks like it might be. But you can see how one side of the cross-section is the side of the square, S, but the other side of the cross-section is actually the diagonal of the square, which is a different measure from the side of the square. So this cross-section is a rectangle. This last one here, this cross-section, you can see it slicing off a portion of the cube closer to us. And we can see that after you slice it off, that what will be left, that surface, is going to be a trapezoid.